We do have a wonderful panel today that's going to really talk more about the applicability of this technology and its true uses in business. We heard a lot of things, both good and challenging, about using additive manufacturing technologies for business. We heard about some post-production and post-process work that needs to be done, and that might be a little bit of a deterrent for use. But we've also heard about saving on weight, saving on material costs, savings on waste. And those might be motivation to use that technology. So how does a business exactly evaluate, is this technology right for me, and what are the pros and cons of actually using it in an application in your business, and what have we seen as a result of that application? And so we have a great panel here that's going to walk us through their individual story. Our format's going to be really simple. I'm going to give as quick an introduction as I can. I'll try to do these four great gentlemen justice. They each have prepared a short PowerPoint presentation. We're going to chug through those really quickly. So please use your pads that were in your packet or any other piece of paper you have there to jot your questions down, because we're going to do all questions at the end, and I wouldn't want you to forget one. But we are not going to break stride. Once we get these guys going, they're just going to keep the pedal down until they get through their very valuable and informative presentations. I'm lucky enough to be introducing two folks we know very well already, because they were here earlier on panels. In fact, three were, and one who is new to us. So I'm going to try to get them in the order in which they're seated, which of course is not the order in which their bios were submitted. No, I'm good. You know Bob Zabricki. He spoke at today's breakfast kickoff as our opening speaker, coming to us from TE Connectivity and talking to us about the migration of that company from the time he joined in 1979 up and through current date, where it went from a traditional machine shop to a CNC shop, and then to the application of additive manufacturing in that process as well. We've learned from you great this morning, and we appreciate the opportunity to learn more. There's something special underneath the cape there, and I'll accept that gift on behalf of Don, and we'll get it to his place at the lake at a later time. But we look forward to that. We look forward to that unveiling. Dr. Kasper has joined us. He is the Advanced Engineering Manager at Gentex Corporation. Many of us know Gentex as a world leader in military and protective device helmets that provide full 360 awareness of your conditions, and also integrate electronics, connectivity, and communication in the field or when performing those high-risk rescue, extraction, defense tactics. So we appreciate your time here as well. He received his PhD from the University of Manchester. He formerly worked, prior to being with Gentex, on 737-900 bodies, so he is very familiar with the application of polymers in an aeronautic application. When he did receive his PhD in materials from the University of Manchester from the United Kingdom in 2010, he did his dissertation on, and this I do have to read for word, the chemistry and kinetics of accelerated and interrupted curing of complex epoxies used in aerospace-grade carbon fiber reinforced polymers. Now, reprints of this are available for your vacation reading. I think we'll have a table in the back, and Doctor has agreed to sign a couple of those.
I still get royalties.
He also wanted me to point out that he is an avid fan of the Seattle Mariners. It was the last sentence of his bio.
First place, Seattle Mariners?
The first question he asked, he said, "You didn't write a bio, did you?" I said, "I had to." He said, "And so didn't you?" I said, "Yes, in fact, I did." So I appreciate that. Chris Jost, we've also learned a lot from him today as the CEO of Imperial Tool, a machine and tool company, and see how they applied 3D additive manufacturing technology into their business. And we also got to experience his true passion for U.S. manufacturing, keeping jobs local, creating localized supply chains, and building a leadership team around new technologies. So we look very much forward to talking with you again, and appreciate the time you've already invested in today and in yesterday's time. And Corey Shikoski, we've worked together on several projects for Tobyhanna Army Depot. He's a 2005 graduate of Penn State University with a Bachelor of Science degree in electrical engineering. He actually started at Tobyhanna Army Depot as an intern back in 2012. After graduating in 2005, he started in 2002. When he graduated in 2005, he then started in the Tobyhanna Army Depot Computer-Aided Design and Product Data Management Systems. He has since moved to introduce additive manufacturing to Tobyhanna Army Depot in various applications, and continues to champion the application of that technology within the depot to this day. So we're very lucky and fortunate to have you as well. I think I've gotten through those as quickly as I can in the interest of time. I hope I didn't leave anything out that is important to you. If I did, please incorporate into your slide deck. I'll fire up these slide decks as they're needed, and I think we're going to start off with Gentex.
So it's going to be a bit of a challenge, because when I talk, I like to actually walk up to the screen and point, but that's a little bit high for me. Do you want me to run it, or?
I can, yeah, that eliminates the
probably
whole
easiest
next
that way.
slide thing, yeah.
So to steal in aerospace terms, you said I used to work in aerospace. If you want to know anything about airplane bathrooms, I can bore you to death about them. We don't ship anything that is flying for 3D printing. You can't buy anything from Gentex or OpsCore that is 3D printed. What we use it for is we use it for rapid prototyping, we use it for fixturing, we use it for fit checks. We use it everywhere that we possibly can. We make an incredible amount of 3D printed products. We just don't sell any of them to anybody else. What we want to do in the future, we don't just, our ballistic helmets and our aircrew helmets also have impact requirements. So picture a soldier falling down or an IED knocking over a Humvee or a helicopter crash. We have impact requirements, and some of the rubbers and the lattices that we can print, we see a great future in that and being able to print 3D pads directly, 3D print impact pads directly. And then also we've had some challenges with fiber placement that we think the 3D printing may be able to get us around. And eventually printing hardware, ballistic hardware out of specialized metallic alloys might be something that we'll be looking at. So in Carbondale, just speaking now specifically about Carbondale, I have some of my colleagues here from California and from Virginia as well, but I'm going to focus on what we have in Carbondale. We have 4 3D printers. We have 2 Stratasys Fortis 400 MC printers, and I have this picture up here. The reason why I chose this picture is these are what we're printing while I was down in the model shop. Again, like I said, I like to actually walk up to the screen and point. This is getting a little hard. These were the things that we're actually printing. This is a fixture for aircrew helmets. And I know that our colleagues down in Aegis Sounds down in Virginia, they just bought a similar type printer, but it has a soluble structure, is that right? Okay. So we have the ones that they're printed that you just kind of snap them off. This is what was actually physically printing in there while we were there. We print from PCABS. We haven't done any of it, but we do have the capability of printing in PPS and PEI and a couple other thermoplastic blends. We just found for what we're doing, the PCABS blend is perfect. So we use this mainly for rapid prototyping. We use it for some fixturing. Thank you. Just make sure I got the actual button on that and I don't burn anyone's eye out. There it is, got it. And I should say this is probably running right now. We run them 24/7. We work on 9/80 schedule and this is our Friday off, but I guarantee that one or both of those machines is running right now. We also recently purchased Stratasys Connex 500. This is a neat little machine because we can print multi-material on this. This black part here is a rubber, and we can easily create gradients for shore durometer hardness on that. So we can have a rigid base and rigid parts, which is this white part here, and then we can have a kind of like a grabby rubber part. So this is, in specific, this is a fixture that we use to hold aircrew visors when they're getting coated. So we can hold 4 at a time on that, and the turnaround time on printing this is under a day, as opposed to if we were to make this out of aluminum and then coat that with rubber, it would be on the order of 2-3 weeks. Main Gentex use for this is we use this for fixturing. We generally don't use this particular one for any prototyping. And then we also have, I'm sure you guys have seen this, this is the Markforged, the 3 HTI product that prints composites directly. It's nylon reinforced with either carbon, fiberglass, or a Kevlar. They won't tell me which Kevlar it is, but I'm assuming it's Kevlar 29. This is neat because we can take things that are breaking, things that we print that have broken in various places, run a quick FEA analysis on it, and determine where we need to bulk that up, and we can lay down fibers specifically where we need them. And then we could try the different fibers. Is fiberglass enough, or do we have to go to a little bit extra strength and use carbon? We can also put variable density of these the reinforcement in there, so we can have a part that has quite a bit of carbon in it, or we can take away the carbon. Like I said, again, we use this for rapid prototyping more than anything else. We also use this one for tooling. So future, where we want to see, this is, you may have seen this picture going around the internet a few years ago, but that's an ultralight metal and it's lattices. And if you go outside to the booths, some of the metallic people have some really neat lattices out there. And we think that these lattices can remove weight. And if we can start making these lattices out of plastics and rubber, and I know that there is capability to do some of this, just not on such fine a scale as we do on metal. There's a wide range of applications, including electrical conductivity. We can electrify certain parts of the helmet, then the soldier is not carrying battery packs anymore. Save weight on your neck. Someone, I believe it was Brian Slocum in the beginning, mentions clip technology, carbon 3D. We are actively talking with them about their machinery. This is some neat stuff, and I was talking about impact pads. If we can develop impact pads out of these materials, that's a game changer right there for the entire industry. And then I also mentioned fiber placement. We've done a little bit of work with some fiber placement, but the challenge is that for ballistic helmets, you really want 0-90 orientation, and then when you mold it in a match metal die mold, those fibers move. So if we can engineer where to put those fibers and use that in conjunction with some of the other stuff, and one of the things that Don said in the very beginning was, what do we want out of this conference? Just think about one thing you want. And what I thought was, I want to learn about one thing that was on my wish list that people are already doing, but I didn't know they were already doing it. And I think it was East Stroudsburg University was talking about 3D printing fabrics. Yeah, that can work pretty well for a composite design. So this down the road, if we can just print a helmet, great. Just burning through this, I talked about some of this a little bit. Aircrew liner tools, autoclave tools. We need a material that can handle 250F. I think that we can get there under those kinds of pressures. Compression mold tooling, gosh, if we could build tools quickly. And there was a talk from Lehigh yesterday where they were talking about having steel gradient into copper and 3D printing that. That is something, that's another thing that I didn't know that we could do. And now that I know that, I'm going to be exploring that next week. So here's the business case. The money spent, now this only includes fixtures that we're making for quality, fixtures we're making for production, fixtures that we're making for things that actually get used. I'm not talking about prototypes here because that's a little bit more difficult to quantify. I'm not even talking about things that we wouldn't normally be doing, but because we have 3D printing capability, we would be doing. This is only fixturing that is replacing metal. So in 2015, we spent about $23,000, 2016 to date, $19,000, 2017 and beyond, we think we'll be spending $40,000, $50,000. That works out to next year, I think we're gonna be saving close to $100,000 just on fixturing alone. So I was at a panel last week, sitting on the other side, and one of the questions they said is, how can the FDM industry help or what is it that they can do to help us as a customer of them? So on the other side, flipping that around, what can Gentex do to help you guys? We need maturing production level technology and capacity. Capacity at this point is a big issue. We know that things are getting faster and faster and faster, but at this point for a lot of our plastic parts, injection molding still beats it. So let's work on that. Customizable accessories and spares. We need to be able to certify to mill and other industry specifications. And again, I know this is something that we're working on and that we're getting to. And the more that we do this, the more that we'll be using 3D printing. So ISO 9001, ISO 9100 Rev C capability, as a lot of these are small companies, can we ramp up and do this expensive certification process? And again, always next generation disruptive materials. That's my techie talk thing, and that is what we would love to see. So I'll pass off to the next person. Can't wait to answer your questions.
I only got a few slides. I got about 4 slides, but I'm going to unveil something over here that you people are going to be the first people to see it. There's another area within our company that's really taken off for 3D printing, and it was not an area that I ever expected. And what I'm about to show you here is got about $3,300 worth of material. It's going to pay back astronomical. This part right here, if we would normally get it built, would cost us about $20,000. So we're looking at a huge, huge savings. What is it? It's a white model. My first white model I had to build going back about 2 months ago came to my email. It came from our industrial division and said, need this house built. Like, all right, I just put that over in my trash email. I'm like, you know, I don't have time for toys. 2 weeks went by, got some of my work caught up, and I'm thinking, maybe I should take a look at that model once. So I pulled up the model. Here it's a geothermal model of a house showing solar and geothermal and how we're going to implement that within the industry. I'm like, oh shoot, maybe I better get that run. So I quick got it run, got it off to them. They never realized that I missed it. So I turned out to be a hero, and that was a start, and this just kept going and going. Now this particular model right here, and why we make white models, is for the customers and for the shows that we put on. And we gotta make them cheap, gotta make them lightweight. I'm gonna pass this around so everybody can see the honeycomb structure inside. These models right here only weigh about 20 pounds, and they ship very easily. So go on to the next slide, please. So the applications are very broad, and they are just a white model. And what do you do with the white model? Well, in the connector industry, we use them as a generic form of a form, so that way we can show the customer where we could put cables, where we could put connectors, and it's generic. It doesn't belong to one particular customer. We'll either design it or we'll take some concepts and we'll put it together and come up with a basic model to work off of. So that's what we're looking at here. Is spatial identity of what we're going to work with in cabling and connector design. Okay, next slide. Now, where will you see these models? Normally, these models here cost us, you know, over $5,000 a piece to have made. We're making them now for, you heard this one here, now this is a very large one, but right now we're making them right around, you know, $200-300 on a smaller scale, which is working great. And the other thing we like too, we keep all these models over in a Germany area in one of our offices. We don't no longer have to do that. We can print them at the locations where we need them. This particular one here, they need it in the States, so rather than making it over in Germany, we just made it here and it's gonna get shipped out to a show. I kind of confiscated this one here just for this show so we can see, you know, what we're doing within the company. And I couldn't believe the value of these models. Okay, next slide please. So again, you see the cost, hundreds versus thousands. All these models here I did build. That white one down in the right corner, that's the one I was talking about, my first one I did. That only took about a spool and a half of material, so you're only looking at about $450 worth of material. Support structures, obviously, were just about as much because sometimes you put just as much money into supports as what you do with the product itself. And what we're doing, we're taking a lot of our models off the internet and just modifying them, condition them. A lot of the models are, again, just generic, and put them in our printers and print. Very simple.
All right, so good afternoon. I'm Corey Shikowski with the Tobyhanna Army Depot. I want to kick off by going through just a little bit about Tobyhanna. And all right, there we go. Tobyhanna, we're right up the road here in Pennsylvania, right off of 380, so about 5 miles up the road. We employ about 3,000 plus people here. We do overhaul repair of communications electronics equipment. So that includes everything from the small radio that a soldier uses up to a full semi-trailer that's loaded with different communications equipment or some type of satellite communications equipment. So we're running the gamut. We have full in-house capabilities on most areas. We have machine shop, in-house engineering. We have canvas, leather, electronics shops. Pretty much if we can't do it in-house, it's usually we're not going to touch it, but there's not much we can't do in-house. So about mid-2000s, right after I started full-time at Tobyhanna, we started hearing about additive manufacturing and looking, well, how could we use this for us? And at first, we started looking at it and thought, okay, well, just the models we can create for our customers so we can give them a better idea of what we are going to be supplying them as their finished product. So we took that, found the machine, and we kind of rolled with it, and we got a Dimension 1200. So we used that for about 5 years or so and started seeing some limitations to it. The finish on the models wasn't really what we wanted, wasn't fine enough detail, materials weren't all there, and I'm going to look at my notes here as well. And just some small stuff like that. So we then started looking a little bit more, okay, well, let's get something to supplement this. So we ended up with a Objet Connex 500. So kind of along the lines of what Gentex is running. We have a FDM machine and also the PolyJet machine. So we started using these machines. We've been using them for the past 5 years. Our our Dimension has been around for almost 10 years now. So somebody was talking yesterday the lifespan of one of these machines and what your ROI is, and it really is going to break down to how you use it. I mean, our Dimension has been running 10 years. It's still running. We have a maintenance contract, so as long as that maintenance contract is there, it's going to be running. So some of the benefits that we see is we don't need to retool. When we're creating just a prototype or something, breaking down a machine and having to retool it and put a different material in there is costing a lot of money. We don't want to have to do that. As I said before, we try to do everything in-house. So that's one of those things. This allows us to do more in-house. There's parts that otherwise we would have had to send out for injection molding or something along those lines that we can now do ourselves. Lights out over a week and we're able to kind of just set it and forget it. On the keeping stuff in-house, the injection molds that we would need, they also cost several thousands of dollars. So when we're doing small quantities, our workload is an inch deep and a mile wide. We do a little bit of a lot. So it's small quantities, and injection molding for just a couple hundred pieces just doesn't make sense for us, where we could print them off for $1 or a few dollars a piece instead of spending several thousands of dollars on just the mold alone and then actually having those parts created. So that's some of the benefits we see to additive manufacturing and how we're using it. So I'll kind of show you some of the items that we've done in the past. And sorry, a little slow there. So prototypes and test pieces, as I said, in the upper right-hand corner there, you see that's a heat sink. And I'm going to take the credit for a lot of this, although my design team at Toby Hanna has usually done all the design on it. So, but I'll steal that from them. That heat sink was originally created out of one-piece cast aluminum. A customer came to us looking for that, and we don't do casting, but we thought, well, how could we do this? So our engineering team looked at it, thought, okay, well, we could break this down into a multi-piece assembly and make it a welded assembly now. So we wanted to kind of verify that design and how everything's going to fit together, make sure all the welding could be done on it properly. So we went ahead and we printed off the 3-piece assembly that we would then later manufacture out of metal, and we were able to verify all that information. A tenon safety brace in the lower right-hand corner there, it's a big brace, holds an antenna up, keeps it from falling down while a soldier or a technician is working on that item. A very important safety feature. And then also we have kind of placeholder pieces that you see on the left-hand side there, those 2 pieces. So a lot of the equipment that we work on is very expensive, and keeping that equipment around for a long time just doesn't always work for our customer. Also, some of it might be classified equipment that we can't actually hold on to. So we're able to go ahead and create those space fillers, and the item on the bottom left-hand side, we could also add weight to get the full center of gravity when we're doing the full design on a system that's including that. Small run production. So we do actually use ours for non-critical items, and I do stress non-critical. We don't want to put anything out there that's going to endanger life or injure somebody. So some of the items you see there in the upper right-hand corner is a cover for a dial on a piece of equipment. So that's something, these covers were broken off, no longer available, couldn't find them anywhere. We're able to use our Connex machine to actually print that clear piece with the text embedded right in it. So we don't have to worry about the text wearing off. I believe that it was backlit as well, so that's still able to use that. And we're able to do that in-house instead of sending that out and trying to find somebody that would be able to do that in a cost-efficient manner. We also do some, on the bottom right-hand side there, you'll see there's little dust caps so that we put on pieces of equipment that we send out. This was an item that was going to hold up our production. So, I mean, how do you quantify that? How do you calculate a return on investment of on-time delivery to the customer? When they're waiting for something, if they're waiting longer, well, that might not be a return customer for us. So getting that out on time was critical. We've also been doing some manufacturing support items. So we do in-house cable creation, and one of the items we do on that is then the overmold on those cable ends. So in the upper right-hand corner, you can see we've been starting to play around with using our object machine, or sometimes our dimension as well, to create those molds that we'll use for that cable creation. And I believe that is also what you're seeing on the middle one on the right-hand side there. And then there's also showpieces that finally, you know, sometimes you just got to get something nice to get out there and show the customer what we could do. So one of the items that we've done actually on the lower right-hand corner is, and I got to give Mike credit for this one back there. Mike, raise your hand. Come on. This is a coin for a 3-star general. Was General McQuistion. She was a former colonel at Tobyhanna. She knew that we had this capability, and she wanted to kind of showcase Tobyhanna a little bit and asked, could you take my coin, design it, and print it off? So Mike went into the great detail of modeling up that whole coin you see there, the different shading of all the materials and everything. It's a 2-sided coin that he ended up creating, and she's handed those out to different people throughout her time. She recently retired, I believe, last year, but one of the few 3-star generals, female 3-star generals. And the last one is a mine roller bracket that would go on an MRAP vehicle. So we're able to kind of show our customer what we were going to be doing and show future customers what we've done in the past as well. For us, I mean, it's all about getting our work out there and making sure that we really like this slide, and it's all about the warfighter for us, trying to get what they need to do their job and keep them safe. So that's how we see additive manufacturing, and that's how we're using it.
Okay, so why don't I set the stage a little bit while they're loading the correct presentation up. So we're Imperial Machine and Tool Company. We sell a lot of additive products. We're an advanced manufacturing company. Many of you have heard me speaking before. But one of the slight differences is we have to make a use case to our customers. We have to say, why would you want to use additive manufacturing or an additive manufactured item as part of your constituent assembly or component. And so we chose a very specific example. It's a 4-slide example for one of the national labs. We deal quite a bit with many of the national labs. Again, these advanced, there we are. So these advanced research labs need all sorts of different things done. And so we interact with them on a very regular basis. We ask them, what are your problems? What is it that we can do that might help solve your problems? So in this case, you can see they were looking to improve a 30-year-old design, and really what it is a design that was always created by manifolding things. So everybody here that can picture a manifold, in the old days you'd drill several holes, you would cross drill them, you would plug the ends, and of course you would get fluid going through there, but you wouldn't get the thermal transfer that you're really looking for. And so one of the perfect examples of additive is some manufacturing methodology that would end up getting rid of the these corners in here, so as the fluid would then continue to pass here, you have all the burbling that would take place in these areas. So it's not a very efficient design. So cooling channels were cross-drilled and plugged. Performance was constrained by cooling limitations. Hit that, yep. So, of course, we went the whole routine as we usually do with customers when they first are understanding it. They said, make us the old design using additive. And we, of course, responded back, that's probably not the most effective thing to do. You really want to redesign it in a new manner. That usually takes 2 goes around, and it took 2 goes around this time. And they said to us, look, just make us what we used to have. So we printed a piece here, and we printed round holes in here for them. But as you can see, there's no cross drilling. There's no corners where you don't get efficient thermal transfer or where you get material burbling. And so the first thing that we did was 3D printed them round channels. We did eliminate the cross drilling. We did improve and smooth the fluid flow, and we improved the cooling performance. So, in goes coolant on this side, it comes through, and it comes out on that side. This becomes a reflective mirror. This is a piece of copper that we braze in place. But you still ultimately have a tangency point that is doing the only cooling to a surface. So you can picture a tangency point and its adjacent cooling surface, and the only real thermal transfer that takes place in that situation is at that tangency point. And so we did say to them, okay, we built you what you asked us to build, which is a rerun of what you had done in the past, but how about if we said we can improve the cooling performance even further? And they said, oh, well, show us a little bit more about that. So what we did was we made, racetrack patterns, broadened them out. We made them much wider. You now have, rather than the tangency point being the only cooling point, we then have a surface that is, in essence, an entirely cooled surface. So this then became a very, very cool surface. As we said, holes don't need to be round and straight anymore. We can make them ob-round. We can make them much longer. So certainly all those folks out there that are involved in casting processes or involved in any thermal transfer understand right away the advantages that you could get simply by taking your round conformal cooling, your round cooling channels, turning them into ob-round, and you get much better thermal transfer. So we tried to focus on something that people would be able to seize on and would be able to understand a very simple use case. And so we presented this. What it did in the case of the National Labs is it enabled them to get, it's actually a beam redirector. So it's a energy beam direction device. They were able to get about 2 or 3 degrees more cooling here, and they were able to achieve something that they had not been able to achieve in 30 years. They were fascinated and truly excited by this opportunity. We're further engaging with them how we could even do this in further situations. So in this case, it happens to be for redirecting a beam, but certainly in optical components, optical cooling components, or countless other semiconductor applications or other cooling applications, whether they be die-making applications, very, very similar situations would occur. I think that's the last one.
That is.
Thank you very much, everybody.
What we'd like to do is we have plenty of time remaining for some questions that I'm sure you have for our panelists. If you have any questions, if you could please just let us know and we'll have someone bring a microphone out to you. And while we're waiting for that to happen, one of the things I noticed as we were kind of reviewing the bios and hearing from some of our panelists, several of these companies have been around for many, many years. Imperial, I believe, 73 years, if I'm correct, of continuous operations. Hanna, well over 100 years. Gentex, a multi-generational business as well. What challenges did you have in implementing and integrating additive manufacturing into the business? Not necessarily perhaps financial or operational, but more from a staff receptivity, worker embracing that new technology. What dynamics did you experience there and how did you address them?
I'll jump on that unless you guys want to. In our case, we're an advanced manufacturing company, so we have always made it a point to try to stay on the forefront of cutting-edge technologies, early adopters of things in the 1940s that people weren't adopters of, in the 1970s or the late 60s actually, early adopters of CNC machining, EB welding. So for our folks, we were able to turn it into a point of excitement. Our folks really are fascinated by it. I mean, they're drawn to our additive area. So for us, it was a very, very easy step to make. They just, it just folded right into what we do. So for us, it was really no challenge at all.
Anyone else?
So we brought our additive manufacturing capabilities originally into our model shop, and we brought it into an area where people are used to tinkering with things and where the mindset was already there for, hey, this is a new toy, let's try it, this is awesome. And then we just played with stuff. If anyone came by our stand, I got that one piece that no one can figure out what it was. I'm pretty sure that was just the guys in the model shop seeing, hey, what can this machine do? So there was less adaption there, and then as soon as they start chunking stuff off and having some fun with it, all of a sudden they say, hey, this part over here, why don't we try making this? And they did, and they bring it to QA, and QA says, hey, this is a great go, no-go gauge. And suddenly, instead of having one machine that we're tinkering around with, we've got 4 that are running constantly.
Well, mine was kind of comical. I kind of hid in the test lab area so nobody would see what I'm doing, so I wouldn't get laughed out of the model shop. And once I perfected the operations, that I brought it out, and then everybody was like, wow, this does actually work.
Corey, anything?
I think for us, it wasn't really that difficult bringing that in. It's just going forward, how do we get more use out of it, and how do we keep using it, and getting more of the folks at the depot aware of this, and opening up their minds to ways that we could use it.
Thank you. Any further questions from anyone? Yes, thank you.
Sure. Tim Simpson, Penn State. So Chris, enjoyed your comments there, and thanks for sharing the example. Something that you said piqued my interest, and we hear that a lot as well when companies come and say, hey, I want to do 3D printing or 3D print this part. They invariably want the same design through just 3D printed instead of cast or machined or forged. Any other examples, thoughts, suggestions on how do you change people's thinking or convince them to start thinking differently, just like your quote there, holes don't need to be round anymore. They're round because that's how we're used to drilling them. So any other thoughts, suggestions you could share with us?
We almost always go through the same process with new customers. They almost always want us to build the same product that they've always had, and they said, build that one for us cheaper. And we say, well, we can make that subtractively. And they say, well, we want it made additively. And we say, well, okay, that's going to cost $2,000. They said, well, we can buy it for $20. And I said, well, we can sell it for $20 too if we make it subtractively. So some of the big ironies are with almost every customer, you run across a very, very similar, thought pattern. The ones that get it, the ones that we penetrate too early, this National Labs gets it. Once we penetrate to them early, that individual will understand it. Then the hoped for outcome of that is that he or she goes back into their engineering labs and discusses with their partner next to them, or discusses with somebody nearby. And the hoped for outcome of this is to build excitement and have them come back to us with a little bit more understanding of where it is. So I guess the best way to answer that, Tim, is to say that in almost every situation it starts out as build us what we used to have. We try to talk them out of that. They stick with it for a while. We build them what they used to have. They say, well, this isn't a heck of a lot better. And we say, well, that's what we've been saying. And then eventually we change their world, and we say to them right up front, we can rock your world. In the semiconductor world, we're accomplishing temperatures that have never been accomplished before. We're doing things, Imperial has been we filed over a dozen patents based on additive manufacturing in the last 18 months or so, because there is so much impact on so many different areas. When they get it, and we don't have to go through this, but it takes a while.
Another question, Don, to your left, perhaps? Or Don?
So what I'm struck by is, over the course of particularly today, there were a couple of third rail things that came up. Bob, you brought one up this morning about what you do in your company, or don't do actually, in terms of not having some of the units out. We got into the third rail topic of, are we going to change the way K-12 does things, and we knew we weren't really going to solve that problem here today. But one of the words that we have not used in this conference is risk. And so I ask each of you as commercial corporate leaders, talk to us about risk in additive manufacturing from each of your perspectives, particularly as corporate partners.
So this speaks quite a bit to my first slide and my last slide. I say we don't actually sell anything that we 3D print. We make fixtures, we make tools, we make things that if and when they break, and it doesn't matter how we manufacture them, they're going to break eventually. It doesn't hurt anybody. We're in the business of bringing soldiers home from the battlefield. That is our number one concern. The risk is that then now skipping ahead to the last slide that I had, the risk is that I don't necessarily have a product that I can stamp on it and say it conforms to MIL XYZ 752 beta. Until I can do that, it's going to be very difficult for me to sell these products, and that's where the main risk lies. It's fantastic. It is absolutely the bee's knees for making go, no-go gauges, making tools, making fixtures. Selling it is a little bit tough when, as Chris said, it's all about protecting our soldiers.
Okay, I'll reiterate what I went over this morning. And what we do is when we bring a new technology in and we bring materials in, the first thing we do is look at the SDSs, the safety data sheets, and then we want to try to protect the employee. That's where it all starts. So if that means we have to spend $200,000 for a room to put a metal sintering type machine in, then we do. That's number one priority. Of course, we take care of the employees by the PPE measures and everything, all the safety effects that we have to do there. As far as handling all the materials, the same thing there. We make sure everybody's protected with the right PPE, everything's disposed of properly. We take a lot of pride in personal protection for the employee as well as the technology itself. The same way when we're looking at any kind of new materials. If we have a new material that has not been, released, or we're just developing it, and we may say test it out on a proprietary printer, we're going to get our resin people involved in it, and then we're going to have them analyze it to let us know, what is the maximum temperature we can go to before any kind of volatiles will be released. So, we do that. And again, with any kind of the tabletop units, we try to, get the enclosures on them and get the ventilation. So safety is really number one for us.
So I think I'll jump at that from a slightly different angle. Of course, everything that these fellows said so far applies to us from a risk standpoint. Our biggest customer is the U.S. Department of Defense, so it's very important, obviously, that we handle all that risk. But the risk that I would point out to you folks, for somebody like us, 73-year-old manufacturing company, I or my family have owned it for all those years. One of the biggest risks for us is staying relevant. We have to stay relevant to the world. We have to be able to offer people something that they want to come to us and buy. So a big risk is simply staying relevant. Many people in my position several years ago would have opted to stay away from something as risky as additive metal, SLM, additive metal. For me, the risk was commensurate for us to be able to do that. If I didn't get into this, what is my next generation going to do? After 73 years, and I wanted to be a 100-year-old company someday, what is the risk associated with not getting involved with something like this? So risk can be looked at in a different manner, and for us, a risk of not being involved in something is significant. I would also say that we have stomach for risk. My company and myself are entrepreneurs. We have stomach for the sort of risk at $2 million into a technology that we haven't sold $2 million worth of stuff for yet, but there's risk associated with both sides of that. So
It's basically repeating the same thing that's been said. We can't send anything out there that we don't know is going to be safe for the soldier. The military certifications are very, very stringent, and standards on additive manufacturing right now are very, very non-existent in many areas. So we don't have those standards to go at. As some of you heard earlier, if you have an SLS machine, you could print in opposite corners and have a part that's slightly different. And those properties, that slight variation could be very, very critical. So we're sending out stuff that is of no risk. That knob cover, if it falls off, it falls off. It's not gonna, nobody's gonna get injured. Those little cable end covers, those caps, the soldiers rip those off as soon as they get there, but it gave us the ability to get that item out the door So we're just have to be careful where we use it, so we're not putting it in an area that somebody will be at risk.
Yes, and Dale.
I guess this question would probably apply to Chris and Corey more. As a former manufacturer and now as a consultant that talks to manufacturers about innovating their processes, how do you make the decision and make the case to use it in production? I think at Toby Hanna, you're using it in production to some extent, and Chris, you're using it in production as opposed to just prototyping or for parts. So how do you make that case, and how would you, with some of the risks that you just talked about, how do you make that decision when you produce something using 3D versus conventional, and how would you make that case to a manufacturer that is thinking about getting into this technology?
So again, for us, we're not putting out items that are critical that will risk anybody's safety and well-being. We're supporting equipment that is, in many instances, 20, 30 years old. It's quite old, and getting parts for it is just not a possibility. So a lot of the stuff we're doing is small pieces that are plastic anyway, circuit card clips, little covers going over a battery or something like that. So for us, what it comes down to is if we could get this piece to get that product out the door in a safe manner, then we're going to try to use that if we can.
In our case, it's a several-fold issue. For the U.S. Department of Defense and guys like Corey, it's hard to move that ball down the road because we have barriers to entry, very understandable barriers to entry. In other industries, particularly commercial industries, we have very few barriers to entry from the standpoint, I used the example yesterday, our semiconductor customers, if we make it out of rubber, plastic, or banana peels, they couldn't care less. If they're going to be able to make it faster, their product faster and better, they're ready to pile on. Now, I don't mean to say that it's as simple as that, but if you are able to rock the customer's world, if we're able to say to them, we can change how you've been doing things, and we can add to your bottom line, they pile on pretty early, particularly in the commercial world. Best way to use it is when you're innovating, when we're trying to develop the innovation process, when we deliver true innovative things, when they're able to make deep UV LED bulbs at a cost factor that will probably be something like 20 to 30% of the existing cost of making deep UV LED bulbs, and you can field that, for example, in China, where they use those deep blue LEDs to clean water and purify water. You're going to change everything around. Those people are lining up already. They are already starting to line up, and we don't have to do nearly the things that some of these other guys would have to do, or I would have to do in my US DoD work. I just say, well, take a spot in line, we'll get ready to, change your whole fab and what you're doing on your fab floor. So it really depends on the end-use customer.
So this is the one instance where I'm going to say that aerospace was easier than the current business I'm in. When I was in aerospace, we were working on an STC project where we had some ductwork that we wanted to make out of polyethylamide, and we wanted to 3D print it. Polyethylamide was BMS qualified. We got it from Sabic. It was no problem. It was on the QPL. The way that we convinced them, it was very simple. It was an STC program. All we had to do was go through static abuse loading. It passed. It's on. Good to go. So in that particular instance, it was pretty easy.
I think we have time for one last question, if we may.
Well, hopefully this won't take long to answer. You can answer yes or no, or you can go on to
No.
be verbose. Yes. No. Okay. Well, there we go. And thank you all. One, I see some significant innovation going on in your 4 companies up there. The question I have is this: are we there yet? Is additive manufacturing and the additive manufacturing machines that are available today, are we there yet? Can we, what do we in academia and in the research areas need to be doing to support maybe going to the next step? And because I heard, we heard Bob talk today about accuracy issues with some things, and we hear that, you know, we can't put products out because of safety. Most of the time we use these things for, you know, for developing molds for products that we can then sell. You know, very few and far between are we getting products that are being built through additive manufacturing. From what I've heard here, it's being used for a lot of prototyping and things like that, proof of concept designs. Are we there yet?
Scalability, reproducibility, certifiable. That's what I'm looking for.
Hang on, this is just the beginning.
I mean, I don't know when we are there will be. We're not there yet. Are we there with cell phones yet, for example? I mean, we started all those years ago and they were bag phones. You know, now we got them with us ubiquitously. But are we there yet? I don't think we're by any stretch of the means there with additive. We certainly think that we're in the very, very formative stages of it.
Yeah, it's been around for 30 years, and you've only heard about it in the past 5. There's a lot more to come.
And Bernie? The one question after.
We need to come up with an end product, or, you know, when you're doing subtractive, you're not selling the drill bit, you're using the drill bit. Maybe this is the same type of tool.
If it ends up yielding a usable product, however you get there is of insignificance to many people in the world. So I would say it will be both a tool and an end-use product. I happen to feel that in northeastern Pennsylvania, for example, we could be, when we talked earlier about a room like this of additive manufacturing machines working by themselves, I think of who's building those additive manufacturing machines. I think of the people that are the companies that are going to be making the hundreds of those. That's where we want to be. You know, so that's what's going to drive it. So there's a two-headed part of that. Yeah, we may lose manpower in what we used to call the typical blue-collar industry of guys feeding machines, but we still have to have people making the machines that they're going to have to feed out there. So I think that this is the beginning of a rebirth, and that whether you look at it as a tool or whether you look at it as the end product, it's going to change things around radically.
Great one. Absolutely. 3D printed cars, they're on their way.
Well, I see a 3D printer as no different than a match metal die mold. It's a tool. That's exactly what it is. So I think your drill bit analogy is apt.
And on that, in order to keep us on time, we do have a break. After that break, we'll re-meet here at 2:30 for what will be our last panel, and then we'll have a nice wrap-up. But please join me in thanking our panelists. Many of them are pulling double and triple duty, so thank you.